Good morning, everybody. I think that it's time to start with our today webinar, which will be focused on the problem of agriculture in the relation to the climate. We will have two main presentations. First will be about agro-climatic zone scenario from Karel Jedlička and Pavel Hájek, and second will be field accessibility tool and its component from Marcela Doubková from PESSL instrument. At the beginning, I will give the floor to Pavel to start us every this webinar with a small questionnaire. We will have for you two questions on the beginning and then a few questions on the end. Pavel, did you put to the chat the link?
Yes, I just didn't press enter, so give me a second. Yeah, there we go. In the chat you have the link for the Mentimeter, and now I can share my screen with the questionnaire, which is in here. And there we go. We can vote right now, either using the code at the upper part of the screen, or you can use the link as well. And okay.
So it seems that we have some good mixture of skills. It is good.
Yeah. So let's move to the second question for today's voting, and it's about learning about EUXDAT project.
So it seems that as in all previous webinars, direct contact looks as the most relevant for promoting this event. I think that it probably are all votes, and
Yes.
we will go to some first introduction, which I will try to do. Pavel, did you finish your?
Yeah, I unshared my screen, so feel free
now
to
I will.
share your. Yeah.
Now I will try to share my screen. Okay. Okay. Do you see my screen?
Yes, we do.
I have to say that not only during the EUXDAT project, but also in other activities, we recognize that climate is one from the key drivers which will now influence the agriculture, and it is important to put much more focus in the future on the not only on the research but also on developing and implementing tools which will help to the farming sector to mitigate climate changes, but also will be important to try to reduce influence of agriculture on climatic changes. Probably you all already heard that the Commission is planning to or starting to promote this Green Deal. There are prepared also research project which will, the call is open and proposals are submitted in January for this. They are the big things, and it is important to work and to be prepared, because there is a number of obligation in the Green Deal for farming sector, and it is important to find the good model where public and private sector will cooperate on the way to develop new tools, new technology, new IST tools to be possible to adapt on the climatic changes, and to be also possible to fulfill obligation which will come. In a Green Deal, in EUXDAT project, we develop the infrastructure. This infrastructure was presented, I think, on Tuesday. This webinar is on web. You can see the video from this. There is not only presented infrastructure, but what is also, I think, important that our colleagues from Spain and French presented there also how to parallelize problem, how to write parallel code in Python, because many cases mainly related to climate are not simple task. It is difficult to make this analysis on some small computer. You need usually some bigger infrastructure and you need parallelization. So if you are interested about this problem, look on the video which was done in previous. Pavel, maybe that you can share to the chat the link to the video, which could be useful for people who didn't participate. And then we have series of webinars which are demonstrating how this infrastructure could be used for farming, and also how it could be used to deal with this European Green Deal, because European Green Deal came during the project period, and what we recognize that we can offer a number of services and infrastructure which can help to overcome all this problem and things which will come to farming sector with this Green Deal. Of course, it is also related with global scale with Sustainable Development Goal, because the Green Deal and Sustainable Development Goal are very interlinked, and generally Green Deal is based on this Sustainable Development Goals. Here are mentioned some climatic actions which are expected and planned for the future. Of course, not all is related to the agriculture, but you can see that there is necessary or they will be important for national bodies to include agriculture into emission trading, that it is important to look on forest and land contribution to fight against climatic changes, reducing greenhouses. Also, energy efficiency is something what could be done also on the level of the farm. So there is a number of things which are relevant for agriculture sector in this, but as I already mentioned, not all has to be solved by farmers, because farmers are able to solve only small parts, and also it is necessary to provide some changes in common agriculture policies, because if farmers will need to fulfill these requirements coming from them, it will be necessary to subsidize some part of activities or some part of the technology for farmers to be possible adapt on this Green Deal action. I'm usually telling that to be possible to do this, we need to build effective knowledge management. And knowledge management is something what is starting from data. So we can deal with the data from sensors, we can deal from the data from Earth observation, drones, aircraft, other measurement. We need to have some platform which will on one side guarantee access to this data and which will be able to transform this data into information, and then it's important to build the knowledge about this. This knowledge here, we will need to cooperate a lot with the specialists from agriculture sector, yes, because we as IT person can serve the data, we can provide some analysis of satellite images or other, but then it's necessary that will come anybody from farming sector and will say, okay, this can influence in this way the production, there is necessary to apply such method. People are discussing, yes, for example, if we are speaking about precision farming, if we have to focus on increasing of production, or if we have to focus on decreasing of use of fertilizer or other. So there is necessary to build a big knowledge on the side of the farming research, and but it is important to connect this with information technology, and on the end we need to build the wisdom of farmers to bring this knowledge to them and learn them how to apply this knowledge into their everyday life. Here is some basic infrastructure of EUXDAT, which could be considered as one from the tool which can help to collect this information and on the top build this knowledge for farmers. And now we will move to the presentation, which will show some demonstration how this technology is or could be used for building of the knowledge in different areas. I don't know who will speak, if Pavel or Karel. Oh, Karel. As a Karel, it is not me, please. Yes. So in the family we call him Smrk. What is in the Czech? It means spruce. So spruce. Floor is yours.
Thank you very much, Karel. I'm just starting my screen, and thank you for the introduction. Hopefully you can see my screen now.
Yes,
so,
we can.
Together with Pavel, we will talk about calculation of agro-climatic factors from global climatic data, a bit similar activity you saw already yesterday on the webinar, but I would kind of stress the differences during my speech. Well, I will go directly to what we want to tell you. Basically, we want to tell you a story of a farmer who is searching for some particular place where he or she can plant a particular plant, and he wants to know the suitability of the place based on relevant data and up-to-date technology. So this is what we want to achieve at the end. Now, how we would like to achieve that? Basically, we can describe a place in the reality, in the environment, by several climatic variables, which we can turn into so-called climatic factors. And when these factors affect the agriculture, we call them agro-climatic factors. So they can be related to sunlight, these factors. They can be related to water balance, to temperature, or even to soil temperature. So these are agroclimatic factors we can calculate. And then, as I mentioned, at the end, it influences the plant here. In contrary, what we found in related works, we would like to do the calculation not from local data, but from global data. We want to have deep description of each algorithm we use. So this is what we bring as our output, I believe, as you will see. And we can offer an environment where you can repeat the calculation by yourself, so you can do your own analysis if you want. How do we achieve that? This is basically by having the data, the algorithms described on this page. It's a GitHub page where you can find the deep description of each particular algorithm. And you can also download the code of the algorithm. So this is where you can get further detail if you are interested. Okay, we'll continue. If you go through, there is not such a time to go deeply through each agroclimatic factor, but you can look at the diagram and search the information how, for example, here the frost-free period is calculated. There are basically two ways. One is to calculate it just from 1 year, then it's clear. But if you calculate it from a period of years, you have to deal with some probability, because each year let's say the last freezing day and the first freezing day at the beginning and end of the season differs. So to show you for a better imagination, I will start with speaking about a story of a place. Imagine you have a place of particle coordinates, for example, these ones, and you want to know about the factors in the place actually. So for example, you can calculate, as I mentioned, the last and first freezing date from this. You can calculate the frost-free period. So far, so good, I guess, for imagination. But if you talk about analysis of, let's say, 10 years period, you search for, if you are a farmer, for example, you want to be sure that after particular date, there is not going to be freeze. So you're searching basically for low probability of the freezing in the particular place. So for that, you can get a map such this, and you can see what is the last spring frost date with the 10% or with the 90% probability actually. You can set up another threshold. Of course, you get another map. So this is, it doesn't have to be just about the place, but about the area as well. In a very similar way, you can calculate growing degree units, growing degree days, or heat stress units. You can calculate it for each particular year, but of course you can look inside the year, and you can actually search for each week, each day, each hour, whatever you want to. From the soil temperature, you can search for nitrogen application window. Again, the description is somewhere in the GitHub, as I mentioned. The solar radiation, you can calculate as well how much solar radiation is needed for a plant, for example. So this is the accumulated curve. You can calculate the water balance, which means the difference in between precipitation, runoff, and evapotranspiration. So again, you can search for years. You can look for a particular period, if in the year, etc. We spoke about, or our colleagues spoke about how it affects the plants yesterday. So I would recommend their webinar to go deeper in the relation of the plant and the climatic factors. And I would in the rest of the time, I would like to present the data we used because we used different data. We used open data, which can be found if you click or if you search for ERA 5 land hourly data. You can get the same data we had for free, just the registration is needed. And we were curious about the precision of the data, the inner precision. So we elaborate it a bit about the precision. There is a so-called EDA dataset which describes the precision, and you can see that it has pretty small standard deviation, and the minimum and maximum is pretty good. And what is really important is to see that it's more or less same precision each year. That's precision. Accuracy is another question. So we compared for 2 years, for a year here, the data to a weather station and data from the weather station. So you can see the correlation here is quite good. What is worth to see is the diagram of the differences. Actually, the difference on the temperature in this case in between the meteor station and the global data. And here you can see that you can see standard deviation at about 1 degree, and from minus to plus 3 degrees approximately. So this is not that good, but not that bad for some of the factors. We are still working on how the uncertainty transport from the data to the factors. In fact, this is an ongoing work. And just to show you some outputs, I will speak about the technology. Karel already mentioned the EUXDAT platform. So we use the EUXDAT platform. Here you can create an account and log in and work with the algorithms just with your browser. So it's not about the algorithms are here, but you can use them from the browser and play with them by yourself. And there is also a graphical user interface, at least for some factors ready. So I will now give word to my colleague Pavel, who will describe the graphical user interface we have in the EUXDAT platform as well. So I'm starting the video, Pavel, and
okay, thank you very much. On a URL, which is frostdates.test.euxdat.eu, you can find our graphical user interface for calculation of frost-free periods. There is an initial screen with description of you already heard from Karel, and this is what you can do with our graphical user interface. First of all, you need to set the area of interest and choose it to be calculated, the data within the area of interest. You can set the parameters for calculation. I'll keep these settings as it is. And now you get the information calculated based on the data. You can inspect either point by point, or you can download the GeoJSON with all the points calculated within the area. And when you hit the start, you can start again from scratch. So this is the very short description of how the graphical user interface for calculation of frost-free period factor works, while you can have the data in 2D display, let's say. But as you saw, the factors were calculated not only for a very small area, because the Area 5 land data set has a coverage of the almost whole globe for last almost 40 years. So you can calculate the factors wherever you want. It has one limitation, let's say, that the spatial resolution is always 0.1 to 0.1 degrees, regardless the place. So for the distance between the points you saw in the area of the Czech Republic, Central Europe, the distance between the points is roughly 4 kilometers. On the equator, the distance between the points is about 11 kilometers. So we don't calculate, or what you saw from a point, point of view. Karel showed you the graphs. it's one of the points of the grid from the data. It's not a particular place wherever you click. That's just what I wanted to say. And now when we calculated for the larger area, of all the factors, in fact, we can have the 3D visualization of the data as well. And you are about to see, yes, please click on the video. You're about to see the 3D application representing the data calculated on the area of Pilsen region. You can choose either from yield-related factors, such as length of growing periods, or from the rest of the factors. The other thing is the timeline here, while you can visualize the data year by year, because they are summarized or gathered on a year basis. Each of the factor has its own abstract just to explain what you see. And you can have the information about the factor directly from the graphical user interface of this application. You can visualize not only the frost-free periods, which we are talking about, but the other factors as well, because they were calculated. And you can choose different time to inspect what's the trend within the data. As you can see here for year 2012, which is in yellow, is decreasing water balance. What's in the bluish color is water balance over the average, let's say. And of course, it's a 3D visualization, so you can inspect the data in 3D in order to have the better imagination of data. So this is the 3D version of visualization, the data calculated within the Jupyter notebooks, which are the tools for calculation on the EUXDAT e-platform. And where can I find a link for this tool? I will put the link to the chat afterwards, because we are about to finish, as I believe. So I ask Karel to put the last slide of our presentation. And to wrap up, yes, to wrap up, we were talking about the story of people, of a person, of a place, plant. We were deeply into data and technology. And on behalf of all authors, I would like to thank you for listening to the story. And now it's time for more questions if you have, or we can postpone it to the Q&A section at the end of this webinar.
I think that we have time, so if there are some questions, it will be good when all is fresh. So please, you can ask my colleagues. They will, I hope, try to answer you.
I put the link for the application in the chat for the 3D visualization of data. It's a static one, so you are not able to run it by yourself. It's just for the purposes of visualization of the pre-calculated factors, just to say.
So, are there any question now, or?
Well, maybe I will. Hello, Marcela, Doubková, PESSL Instruments. I'll be the one presenting after Pavel now and Karel. Seeing a 3D representation of agricultural data is a relatively new thing. Not many people, at least I have not seen that many times. Maybe if you want to comment, as you entered this this field of agriculture with the 3D visualization, what are your further thoughts where these things could be potentially applied? And where are the constraints that the visualization actually might not help in some cases and might bring potentially more information in other cases?
Karel, Bruce, I think that it could be probably for you because you are 3D expert.
Well, thank you for the question, Marcela, because it's exactly the point. We are actually in the phase where we prepared something. This is, to be honest, already obsolete version of the application. We are working on another one, which would be maybe more informative to the users. But my answer is we don't know. The best answer. We will see because there is no user testing done yet. So we first have to come up with something. So we believe, but this is just a subjective feeling. We believe that for some type of information, it could be useful to explore actually the data in 4 dimensions. These are in fact 4 dimensions because we talk about the 3D and time. And it's sometimes it's hard to understand, but for now, looking, for example, into the frost-free period, I can find that some places, even in a, let's say, not that big area, have really different frost-free period. It's caused by the Schumann Mountains, I guess. But for example, even better, you can see that if you go for the water balance, so you can see how the landscape actually is. I now cannot work with the mouse properly. Sorry for that. But you can go through and see how different actually the water balance, how it differs during various years. So this is various years and places. So this is something which you cannot easily spot from other sources. You know, you can see some colors on the 3D map, but if you like see how much millimeters actually are missing here and these places, it's something which could be more informative than to use just classical interfaces. But as I mentioned, for now it's like my feeling, maybe Pavel's feeling, and the user testing still needs to be done. And of course, such a visualization we expect it will be targeted more for expert than I mean experts, the advisory companies, than the farmers who have a bit different expertise than IT. So this is something we discussed many times. Yeah.
Okay, thank you. I think this is a good start to be able to play with that. Also I will forward it to our company, and I think we might get some first feedback.
Okay, thanks.
Karel, if we are about this 3D, I think that there is also probably important, yes, for analysis combine this with digital terrain, because we saw in the Rostěnice the influence of digital terrain on the crop. It play important role. So there probably is a very big place for the future in 3D.
Yeah, that's thank you for mentioning that. That's actually other thing. It's even the visualization at the end doesn't have to be 3D. Maybe it's relevant for some cases, for some not. But the topography itself plays important role for sure. So this is where the 3D analysis is actually very important.
Okay. Some other question, comment? If not, I would like thanks to.
There is, I think, one more question from František. Sorry, I don't see the other name, but we cannot hear you. I just see you on the camera. So if you can maybe like type it in the chat. Well, I just see František talking, but not.
Yeah, we don't hear you, František.
Maybe he's not talking to us.
I don't know.
Okay. Anyway, we can came back later to the question. So
yeah. Okay. So, Karel, I would like to ask you to stop your screening, and I would like we saw František, but don't hear anything from you. Okay. So, Marcela, I think that you have now switch your screen and start with your presentation.
Hello.
Hi.
Let me just do the. No, that's not the correct way. Sorry for that. Some menus disappeared as I started to share the screen. Here we go. Yeah. I will be presenting work that our institution with the PESSL instruments, together with our other colleagues within the EUXDAT consortium prepared that relates to field accessibility. It's a field accessibility tool that and multiple components. Something is available via user interface, something via Jupyter notebooks. I'll be talking about the methods and show you some demo as in the previous example and summarize the whole thing. So when we talk about field accessibility, it's important to say what do I mean? What do I mean with field accessibility? Simply when a tractor wants to access field in these dates, in these latitudes, he might have problems because of mud. So to be able to monitor these very dry or very wet conditions, we started to think about a tool that would combine multiple data sets available within the EUXDAT infrastructure to give as much information to the farmer about this value. As some of you might know, the field accessibility is very much dependent on the amount of water in the soil. Clearly, it's also impacted by the weight of the machinery, by the type of the machinery, and by the vegetation that grows. So we already have some service within PESSL instruments that provides this work planning tool for field accessibility, but this is based only on rainfall data. The thought for many years was to develop a tool that is clearly linked to a soil moisture direct in the soil. For this, you need a soil moisture data set, clearly. Given that we already have many thousands of clients that purchased and are using for many years soil moisture instrumentations that became also cheaper within last years, coming to dozens of dollars or euros, we thought that this might be a good way. So we simply take available soil moisture data. Within EUXDAT platform, some of these are available for free. For other, for future usage of such a tool, clearly the user would need to purchase them from our or from different company. We also considered soil moisture forecasted data that were kindly provided by the MeteoBlue company within the EUXDAT consortium. And then we use a freely available DEM model where WirelessInfo supported us with some algorithms that are that are computed above this data. The input-output information informs user about field accessibility. To give you a better feeling, it ranges from the field is not accessible to the point where the field is easy accessible, also with heavy machinery. I think you got already a nice feeling about why this is important. Many farmers actually know this point when they can no longer enter the field. So situations like on the right image happen rarely, but it still happens. If you have tool, as we are now introducing here, you can potentially much better plan your work during the day and during the week. You can avoid those fields where access might be complicated. If you know in 2 days, it will be much easier. You can better plan when and where to irrigate or fertilize according to the information I'm going to present to you. And you can also probably better know when to plant, sow, or harvest your crop. So I go directly to the methodology. As I said, many tools that are providing field accessibility use rainfall and weather forecast data. Our tool is different with that fact that it goes and uses soil moisture data sets. These needs to be located directly in the field. Soil moisture measurements are available from multiple different types of soil moisture sensors that rely on different technologies. But in many cases, they represent the profile. So you can get information from 5 to, let's say, 1 meter depth. And this is also very important for our tool, because according to the machinery type, you can look to the depth that most probably interests you. After we consider the soil moisture data, we also compute some relatively easy indexes from the digital elevation model that tells us about how the water actually flows within the field. The algorithm is relatively easy. It's available within different GIS softwares as a freeware. One of them is, for instance, Saga software that also includes this, provides this algorithm. And it takes the elevation data and considers the slope and also the direction where the water may potentially flow and accumulate. According to this, you are provided with an index that according to the algorithm, because there are many algorithms that can be run, has some sort of range. And I will not better talk about the values because different algorithms may have different ranges. What is important is that the higher the number, the lower the probability that the water accumulates within the field. As portion of our service within EUXDAT project, we also developed a tool that provides you information about phenology, which means the development of vegetation within the year. For this, this is an additional service that also can be used as a part of a field accessibility tool. And when you run the service, you see how the biomass actually developed from the beginning to the end of the year. As a last component of our work within EUXDAT project, we developed a tool that represents management zones. These are sets of pieces that when you bring them all together, you simply can plan your work better. And we do not provide a clear description how to combine them. We are convinced that a farmer finds his or her own way. As to the management zone, which is shown on the screen, it is available already with the user interface. You provide some dates, borders, and the zones that historically provide the same biomass potential are shown with different colors. So this was the introduction. I will go and present the actual user interfaces. When you go to the EUXDAT website, Our scenario is available under information support for field use recommendation. And I will show you the two tools so I was right now presenting. The first one was the phenology. I already have some fields. I will not bother you with this because you saw it within the other presentation. So I have this field. And let's say that I want to learn how the vegetation developed from 1st of January until today. The request goes via Mundi service that was part of the EUXDAT platform and provides you with so-called PESSL service that is a statistic about the phenology. Please look with me on the middle curve, which is actually the mean of the data. So we go from 1st of January until today, and the service considered all available satellite data over the entire field, and we computed the mean per day. So this is the middle curve. So you see there is some sort of increase. You most probably might have been some sort of potentially mice or something, lower mice that starts to raise in beginning on July and then slowly decrease. I'm not sure about the crop. This was a random field, sorry for that. But it goes to leaf area index 4, which is a proxy for a biomass. So you get a nice feeling how the crop develops. You have a nice feeling how the entering of the field might be. So there is still a lot of biomass happening. So, the seeding happened around mid-May. The other tool I will present here is the management zone. So for the same field, I will run this tool, select some dates from which the management zones should be computed, and compute them. As you see, there is a lowest yield. I selected some dates that were actually too. Most probably there was very low biomass within these dates. I will try and select some other dates. As a farmer, you have a good feeling about these dates. So you select those where the heterogeneity of the field is probably the best. So, and some sort of okay. Let's do one last try. And other than that, you will play with that on your own. I will not get stuck here. One last. So let's see if we have better luck in June. Okay, here we are. So we took these dates, and it considers the date that is closest to the start date. And from these images, it computes the management zones. So this was the second tool. And as a last thing, I want to show you the real field accessibility tool that also takes advantage of these user interface portions that I just introduced you. The last tool is available as a Jupyter notebook. It's in the last stage of development. You cannot access that yet. It's not at the same level as Karel Jedlička's tool as he was presented. We are a bit slower. This tool takes so much data. takes Sentinel-2 biomass data. All these things are available via API requests. It takes also MeteoBlue data, again, another API request. So now you see a bit better to the back end of the thing. It plots some results. So the first output of this tool looks something like this. We have dates from 1st of January to today and historical soil moisture data. As you see, these peaks are representing some rains, and as the water seats, then the water available decreases up to some point, and again some rain, and so on as it goes. Red curve represents soil moisture data from MeteoBlue. These are forecasted data until 1st of November. I also provided some ranges. These are the dark and light yellow color and green color. These are ranged based on the field capacity and refill points. So we have some levels. I know that now in this stage, the field is extremely good accessible. It's getting worse here. And here farmer should already consider if he wants to enter with a heavy machine or not. And this is based on the points from the driest refill point to the wettest field capacity. These are provided from the user API. So this is kind of output as a first image for the user, that I would know that following 7 days, the access to the field is actually very good. The second output of the last service I'm presenting is a set of 7 maps for following 7 days. We consider the topography. I know that this field ranges actually from north to south, is slowly elevating down. Therefore, the ability to, the probability that the water accumulates in these portions of the field is higher than the water accumulates here. This is represented by the indices. And as we go within the weather forecast, because the first image represents today, and the next tomorrow, and the day after tomorrow, and so on, going to the 29th of October, you see that the index doesn't change much. In generally, the accessibility is really relatively good, but it decreases on the 29th of image according to the weather forecast and the soil moisture forecasted, as you see here. And at that day, you can judge that the northern portion of the field is going to be still relatively good accessible, whereas the southern is already to consider to enter with heavy machinery. So this is the last tool. I go back to my presentation. I hope I didn't exceed too much, just 2 minutes, I think. Most probably I should not include these links because they are not yet active yet for all users. To summarize, for the tool I just introduced, we used PESSL in situ soil moisture datasets, but datasets also from other accesses, from other companies or from your own meteorological station can be used. We also use MeteoBlue forecast for soil moisture, satellite Sentinel-2 data, and DEM from shuttle radar topography mapper. Portion of these services are available via EUXDAT infrastructure. Potentially might require user login and are available against payments. And to address the actual infrastructure, EUXDAT infrastructure, portion of our service will be available as a user interface, and the other portion is available as a Jupyter notebook. So if you remember this overview of the services, we are actually ranging from here, giving you some sort of Jupyter to play with, and going also to some other services that are already available very easily via user interface. Both has its advantages and disadvantages. User interface is fixed. You cannot really do any sort of additional analysis and edits. With notebook, when it's available, you can play a bit. And if you have idea about your own changes to the algorithm, potentially you can also apply them. So this will be all from me. Thanks a lot for the attention. I'm stopping sharing.
Thanks, Marcela. Are there any questions to Marcela? So please take this opportunity and ask Marcela if you would like to clarify something. I think that it is the good chance to speak with her. So no questions. In such case, I would like to thanks to Marcela. Pavel, before we will start with this exercise with the question, I would like to mention something. The project EUXDAT will finish in 1 week, yes, we can say now, but it was agreed with the partners that we will guarantee that infrastructure will continue running. It was moved to the WirelessInfo cloud. We will guarantee the accessibility to these tools, and there is also the possibility to test it or use these tools after end of the project. And of course, there is also a chance to reuse or use something what was already done in running or future projects. So we will be very happy if you will contact us and discuss with us how these things could be used. And now Pavel prepare for you again few questions on the end. So Pavel, I think that you can now switch to the questions.
Now you can use the same link with the same procedure. How
maybe that it will be good if you will again copy this link if some people lost this.
Okay, give me a second. I just need to copy. How would I do that? Yeah, I would like this way. And there we go. I'm sending it again the link for the voting, and I start sharing my screen again. And okay, we will take another question, which is very similar.
Maybe that I can say for the people who are not familiar that Destination Earth is other initiative of European Commission which plan to develop digital twins for all Europe for agriculture to be possible to provide it some deep analysis of climate and other factors.
Okay, thank you for the clarification, and I believe we can move on to the next one, where you can choose multiple options, not just one. Okay, it looks like everybody voted who wanted to vote. So the another question is, how much, or if you are interested in EUXDAT infrastructure? itself. And as we can see, we are. So we probably we can move on. And there's the question about the purpose of intended purpose of using the infrastructure. Well, we are getting closer and closer to the end of the voting. And this question is asking about the relevancy of EUXDAT and Green Deal calls. While the next question will be dealing with the particular call actions, just to say in advance. Let's get to what I already said. There are some areas of the next Green Deal calls, and you can choose via the slider for each call area. How much do you think it's relevant? Great, thank you very much. We have 8 voters, the top number we had this voting. And I believe we are getting to the last question right now. Yes. And I thank you very much for your votes. This is the last question of our Mentimeter voting. So thanks again, and I will give the floor back to Karel. So the floor is yours.
Okay, thank you, Pavel. On the end, I would tell you that this today webinar will be very soon, I think latest tomorrow, on the web, so you will have a chance to see it again or look on some details if it will be interested. Then I would like to invite you for the last our webinar, which will be next Tuesday at afternoon at 2:30. It is still now Central European summertime, as the change is later, and there will be 2 main presentations. One will be from Dimitri Kožuch from Plan for All about some scenarios of open land use mapping in Europe and how was extended this model. And then will be presentation from CERT, from our Greek partners, which will be focused on crop monitoring pilot, which I think combine Sentinel data also with the drone data. So you are welcome to join us join us next week on the Tuesday, and we will be happy if you will contact us and discuss with us how we can extend it, this services coming from EUXDAT, how we can guarantee the future sustainability of the solution, what could be interested. I see here, for example, also the representative of regional bodies. I think that many analysis which was done could be interested for you. So I will be very happy to continue in the discussion, and you can see all the news on EUXDAT web pages, and I hope that we will be able to guarantee sustainability what was done, because this I see as the key aspect, that if some project is ending, that we need to guarantee the sustainability of the result and transferability to the practice. And we will be very happy to discuss and continue with you. If there are some comments, questions, remarks, please, you can do this now. Seems there's nothing. In such case, I would like thanks at first to all presenters who made for us this interesting presentation, and I would like thanks also to all attendants to be here with us and follow our presentation, and hopefully see you on Tuesday, and then later on some practical exercise. So goodbye from my side.
Bye bye.
Thank you.
Goodbye, everybody. Thank you.